It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and guess what? It's that time of year again. My co-host is the one and only Andy Candy Grabner. Hello, Andy. Candy Grabner. Because it's Halloween time.
Well, Halloween is still 4 weeks out, isn't it? What's wrong with you?
No, when this airs, it's going to be like right around Halloween.
Oh, yeah, maybe.
Yeah.
Oh, that actually makes sense now because I happen to be at Star West in Anaheim, so Disneyland, and the whole month of October here is Halloween theme, it seems.
Yeah, it's getting crazier and crazier. I even see they take in the stores like traditional Christmas decorations and paint them black and orange and try to pass it off as Halloween. I'm like, okay, it's getting too much.
That's getting too much, yeah.
But,
hey, Brian, can I say hi to two people quickly?
Yeah, you can.
Yeah, I want to say a quick shout out, first of all, to Leandro, Senior Performer. He was gracious enough to give me his hotel room to record this session because we're both here at the conference, but my hotel is a little further away. And so I walked over and he gave me a quiet room. And the second person I want to do a shout out is Roman Granica. He's one of our colleagues. And I bumped into him last weekend, and on his way, he showed me he was listening to our podcast.
Oh, wow. Awesome.
It was a Friday or Saturday night. I'm not sure why, but he's listening to our podcast, and I wanted to shout out to him.
It's great to sit down with like a 6-pack of beer and listen to the podcast and just get sloppy and listen. I heard it's a thing with the kids. They're even eating Tide Pods and drinking beer and listening to Pure Performance. So
it's the only way to get through those episodes. No, it's not that bad, and we don't want to shy away our guest today. Which reminds me, we do have a guest today, and we don't want to let him waiting for longer. I would like Kam to introduce himself. Kam, thank you so much for being on the show today. We met at DevOpsDays in Boston. You did a great talk about lessons learned from your experience with serverless. I think the title was called "How to Fail at Serverless," and in quotes, without even trying. But without further ado, Kam, please welcome to the show, and then please introduce yourself to our audience.
Yeah, hello. Thank you for having me. My name's Kam Lasater. I've cut my teeth in serverless, and I have the scars to prove it. And at conferences, I think we have plenty of talks on best practices and how to be great at something. And I thought it was a fun kind of twist to talk about all the ways I've failed and hopefully open up some space for other people to tell stories of failure and things that they've learned.
Yeah. And Brian, right, we've done a lot of these shows in the past that we talked about the top problem patterns, the things that went wrong, and then so many. You're right. It's always great to hear how great people are and what you want to achieve, but then you also want to hear the way and the hard steps that they took to get there. And I think that's the great thing about these presentations.
Yeah, as we share our mistakes, others learn not to even start doing them, and they can pick up elsewhere. I always, even going back to serverless, Andy, every once in a while, I bring up that example that you had when you first tried doing serverless, when you tried running everything in serial, and then you're like, wait, I need to make this all parallel, because that was just really stupid. And it's the only way we get past this. So awesome job, Kam. Thanks for taking that approach.
Yeah, absolutely. I had an interaction at happy hour after giving that talk, and we were with some people, and they didn't say that I could disclose the story, so I don't want to tell them, call them out too much, but they talked about this massive failure of a switch in London, and that brought down a whole hospital's phone system, and I find that oftentimes those are kind of hidden in the corner of conferences, people talking about the real deep cuts they've had in their career. And I think as a community of software practitioners, we really need to talk about it more if we're gonna level up and kind of improve the state of our industry.
Yeah. And Kam, to this story, just a general question to you. We try as an industry, as vendors of frameworks or platforms, we try to make it as easy as possible for developers to build new stuff by abstracting all the complexity away. Yet there is obviously complex stuff going on in the backend, right? And I wonder, are we failing as an industry to really make sure that when people build stuff in the easy way and high level languages, or I think now they're called low code, no code, that we really still make sure that they understand the technology underneath the hood? Because, right, even if everything is easy, sometimes basic things in the backend can bring down can bring down whole systems, like as the switch you were mentioning. And I think you also had a couple of examples that we talk about later on with serverless. You need to know certain things about the runtimes underneath so that you are not running into certain mistakes. So how can we educate people?
Well, I think so. My point first was the why of this talk is very much about creating a space so we can talk about it. So that's sort of the predicate here of that. Yes, we're talking about failure. And then the other piece is I think we need to have a little bit more humility about how little we know as a community, as a society about how to build software. Depending on how you date it, we've maybe been building software for 70 years, maybe. When you think about other types of construction that we do, we have, thousands of years of experience building bridges, and still sometimes they fall down, right? And so just thinking through the number of types of software that people have built and the different layers of abstraction that have been built up, we are still very early days as humanity building software and learning about it. So I think we could all just take a deep breath and say, you know what, maybe we're just really new at this and we're still experimenting and we're learning. And like you say, like the classic joke when serverless as a term was really coming to the fore is like, well, there's still servers. Like, of course, like at some point, like a packet is going somewhere and there is actual hardware that is going to process it and the like. So there's always some sharp edges underneath, but I think we should have a little bit of humility that we don't really know what we're doing yet.
Kam, before jumping into some of the examples, I would also like to give you the chance to talk a little bit maybe about the company you founded, Cyclic, if I'm not mistaken. I know you did a pretty good job also at DevOpsDays to not pitch kind of your product and your idea, but I want to give you the chance to quickly at least talk about it, because I assume a lot of the stuff that you've learned in your work with serverless has also inspired some of the stuff that you're doing at Cyclic.
Yeah, absolutely. So you're using, I would say, the European pronunciation. I would call it Cyclic. Cyclic is fine as well. Yeah. If you're in a more American side, this side of the Atlantic. We're a Node.js platform as a service. It's all serverless underneath. So we're really focusing on creating a way for people who just want to start getting APIs up and running, get them out quick, build in just a few seconds. So that's sort of like our target. And we're using serverless technologies, one, because that's something we know, but we think that it opens the door to some really powerful things over the next 10 or 20 years and different ways of computing. I think there's some really good articles out of some, computer architecture professors out of Berkeley and Stanford in the ACM magazine talking about kind of their vision for serverless going forward. A lot of other thoughts there on like how this changes productivity of developers, and sort of the first iteration of the cloud really changed people's expectations about, do they need to be spending time managing AC units and power supplies, and really change productivity of operators. And now we're really sort of seeing a trend into productivity of developers. And so that's sort of where our head is at. And so we have a blog where we write up this stuff, and if people want to jump on that, check it out, subscribe to that, or try out the platform. Any of that is great. But
well, first of all, we will make sure to link to all of the, like, your website, also the presentation you gave at DevOpsDays. The organizers also recorded everything. It's on YouTube, and I think the whole session, like the whole days, the 2 days are there in one big block. But now I think they're also chopping it up, so we'll definitely make sure to link to it. And also thanks for the pronunciation reminder, Cyclic and Cyclic. You're right. I obviously learned pronunciation differently than a native speaker in the US. But now coming to your presentation, you had a couple of great examples that you went through, and you always had a nice intro to a new thing. Like you always said, "Hey, serverless is stateless, right? Who agrees with me?" and things like that. So I really encourage everyone to watch the whole recording of your presentation. But I would like to give you a chance now to maybe walk through 2 or 3 of those examples with us now, and I'll let you pick what those are that you think are the most interesting ones, especially considering that our audience, right, we're performance engineers, site reliability engineers, capacity planning, people that need to operate platforms, even though serverless, is either operated by you guys or by some of the vendors. But still, pick 2 or 3, and let's start with the first one and just discuss.
Yeah, I think that also laying a little bit of context, I started as well with a trigger warning that all of these mistakes were a mistake that my quote unquote friend had made, this hypothetical friend, and that, everybody was, names had been changed to protect the innocent and the not so innocent. So, I think that state in serverless, I think, is an interesting place where people get tripped up a lot. Sort of there's a basic failure, and this is primarily in AWS. I should also give that as context. That's where I've spent the majority of my serverless time. I've dabbled on some other platforms, but kind of the deep learnings, the pain that I've had to learn from has come from the AWS side of things. So state of the life cycle of a Lambda, and how instances of it get created and torn down seems to be kind of the top of the list of pain points. And we saw this in several different ways. And as you mentioned, I kind of had people raise their hand if they agreed with these statements of, serverless is stateless. And then an example of going through, the classic serverless first, like almost hello world is going through and doing some image resizing, breaking some things up. And we got caught with writing these files that we were resizing to /temp, which is the only writable place inside a Lambda. And that was great. And, as Lambda gets recycled, these containers get torn down and that /temp gets thrown away. However, depending on how your Lambda instances get cycled, and this is something that's really obfuscated to you, you can build up files in that /temp space, and then you can run out of disk. And when you run out of disk, that fault causes that Lambda instance to recycle. So, it's a very common error. I think people in the community kind of have seen it now and understand this pattern. But as a, early practitioner, you start to hit this and you get this inconsistent error behavior, which feels very odd. Sort of following along in that same line, we fixed that. We fixed the problem of writing temp files to temp and then either not cleaning up at the start of an execution or at the end of an execution. But we then hit a problem where, based on our load pattern, we were processing these large PDFs kind of in batch, in bulk, through a step function. And if we hadn't been deploying, which again, when you deploy new versions, you recycle your Lambdas. So it's like doing a hard restart on your instances. You have these instances of your Lambda that could be up for a longer period of time or not. And we found that we started to get inconsistent errors even after cleaning out the temp, and we were getting some, a different error coming out of the Lambda, which, again, these intermittent errors, right? That's the hardest thing to solve, because if you can't push a button and make it happen, or you don't know the mechanism by which it's happening, right? Because otherwise you would just be able to push the button and recreate the failure and then test if your fix worked. Also, we described it as sort of like this Heisenberg uncertainty of looking inside the Lambda. We had a system where we would change environment variables on the Lambda to change the debug levels or the logging levels, instead of trying to make HTTP calls outbound to get config each time and then deal with caching and like all this sort of config inside of the Lambda. So, but by changing an environment variable on a Lambda, you trigger a refresh of those instances. So any running instances get flushed, and it's essentially you've just cleared out your temp or you've cleared out any other OS memory space that you might be, if you have a memory leak or the like. So by looking at it and turning on debug, we created a problem where we couldn't see it. And we were also on a pretty high deployment cadence. So if we were deploying every night to that service, we would flush things out and we wouldn't get any errors the next day. So we had to wait till our deployment frequency on that service came down, and we weren't looking at the debug logs, or changing the debug settings enough that the instances would stay running long enough such that we would start to see this error. And what it turned out to be is a file descriptor, essentially a memory leak of a file descriptor coming out of ImageMagick. And again, once it would fail, it would cause the whole Lambda to get recycled. So it wasn't a problem because it would just fail once and then it would disappear. And then we'd start looking at it and we couldn't find it. And the way we had to finally isolate it is we had to turn the concurrency, max concurrency to 1 and min concurrency to 1 on the Lambda. So basically isolate that Lambda instance into a single one. And then we'd have to do a load test for a certain period of time. And we could recreate it then. And so then at least we had a system where we could reproduce this error. In investigating it at the time, we didn't think it was in our skill set or understanding how to go fix that error or pay somebody to fix it or anything like that. So sort of the solution we came up with was to cause the Lambda to recycle itself. So kind of reset a environment variable on the Lambda, which would flush any of those instances. Definitely not a pretty solution. Felt a little bit of a hack, but kind of understanding that life cycle of the Lambda and really getting in our mind how that worked was sort of what masked the problem. And then in the end actually ended up being the way that we solved it. So, which is kind of a little bit of an irony in the end too.
It reminds me a little bit of the days when I was working on IIS with the W3P containers, like the runtimes basically that were hosting, let's say, your .NET, ASP.NET applications where they had their recycling either on a schedule basis or on a memory basis, but then we were just prematurely then recycling these worker processes because we knew at some point they are crashing for whatever reason, and we just kind of took that pain away by just, forcing them to restart at a time where there was low load.
Yeah, early in my career, I remember reading a blog post by Joel Spolsky when he was still at Fogbugs, and he talked about doing just this, that he would do a nightly restart of all of his web servers, which on one hand, kind of was nails on a chalkboard for this just out of college, computer engineer, oh, we can figure this out and we can solve it. But then also just that practicality of, okay, well, does the solution work and does it prevent the problem? And, are we going to spend weeks of time trying to solve this problem, or do we have something that's not going to impact the system that will achieve the same result? And so finding those balances, I think, is really important. And, the business pays for things to work, not always for them to work in the way that we would like to think that they should work, quote unquote. I think some of, going back to the beginning, the quote shoulds is a little bit of what I'm saying we need to examine. That's the most dangerous word in an engineering context, I think, is should, right? It either leads us down a design process that isn't connected with business realities or isn't connected with technical realities, or it blinds us from actually seeing potentially what is truly the cause of the bugs, because we immediately are blocking ourselves from some possible outcome or some possible state in the world. So yeah, should is always a trigger word for me.
I like the dose of reality you just threw at me there. We and probably others in the observability space always come at these problems well, let's gather the information, find what's causing it, and fix it. And in, sitting behind the desk trying to keep all these things running, sometimes it really is well, how do we just keep this part running? Because we have other things we got to focus on and concentrate. And if we can fix this with a restart, we know it's not the best thing. But until it becomes catastrophic, we'll do that and work on the other, put out all the other fires that are even blazing hotter and then get back to this. But we always have this academic view of, well, find it. Let's get to it. And it's I just never really heard it put that way, I guess. I mean, not that it was put in a special way, but I've never heard someone say like, yeah, no, sometimes we're just fine with the Band-Aid, and if it's got to be that, we know the risks, we accept it, and we move on.
Yeah, there's I think thinking through software and software systems, we talk about them like they are somewhat homogeneous, even inside of a single organization. But if you think about the scale that each of them deals with as far as the investment dollars that'll go into the software system or the value returned to the organization, if you think about each service, if you're in microservice or each application, right, and you tried to plot it on some distribution of the value and the load that application experiences, you'll probably see like maybe 3 orders of magnitude in load, maybe more, 4 or 5, right? Some very large organizations. And probably value has a very similar distribution where you have some services or some applications that have a huge value that they're delivering to the organization. And probably this type of fix might not work in those, high load, high value systems, but there's a tremendous amount of software that doesn't run, those 3 or 4 orders of magnitude higher on the scale or on the value curve. So, and I don't think I certainly don't have good vocabulary and language for describing these types of, the value delivered and the scale of value delivered and the scale of load. Maybe service level agreements is or service level objectives is the closest I've heard on the performance side. But all 3 of those really change how I, as a practitioner, am going to approach what is an acceptable solution or what is an acceptable engineering answer to a particular problem or an anomaly.
Yeah.
Hey, I got 3 quick things I wanted to bring up. One, so basically we're often building workarounds to something we cannot control otherwise. Like in your case, you had this file descriptor leak or whatever you want to call it, and then you built a Band-Aid around it. Now the question is, if they fix the problem at some point, you don't necessarily need the Band-Aid anymore, but the question is, how would you learn about that the fundamental problem from a third-party software was actually fixed? And I think it goes the other way around as well, right? Maybe an update of the underlying runtime introduces a new thing that you have that you now need a Band-Aid for, but you haven't needed one earlier. And this is, I think, where obviously testing comes into place. That every change, whether it's your own code or any of the dependencies, needs thorough testing, because you never know, right? Things are not behaving differently in a good or in a bad way.
Yeah, absolutely. I have this kind of thought I've been chewing on with testing and sort of the design choices we make in our testing, and testing broadly, not just unit tests and code written to test the functionality, but our whole software pipeline is a long sort of evolutionary selection mechanism for the types of bugs that we will see in production. So every design choice we make in how we test our software introduces the possibility of a bug, or it doesn't fully test every possible bug, right? So if you think of bugs as, bacteria that we're growing in a petri dish when we're writing code or when we're, assembling systems, all of the verification steps we do are almost like some sort of antibiotic that we're applying. We screen away 99.9% of the bugs. And so there's some amount that get through, and they're constantly being repropagated so that the bugs that we see or the problems that we see in production are literally a result of the design decisions of our software delivery process, which I don't know, I've been trying to think through how to put together a talk and talk through some of the design decisions or failures in the in the sort of value stream architecture that I've put together in the past, and sort of how that manifested in some cases in these bugs or these failures that I've talked about in this conference talk.
Yeah, let us know when you have the story done, because then we'll invite you back. It's an interesting topic.
Yeah, that's really interesting. It's got I'm not even thinking of it probably in the same way you're presenting it, but that's even just what you said there has got a bunch of things floating in my head. So yeah, please come back when you have that.
Yeah, I mean, the simplest first example, just is to like, get you chewing on something, is that if you have an inconsistent bug and you in a test suite, but you let developers keep committing till they get one green bar, then you've just introduced a way that inconsistent bugs can flow through from your dev system into your test system, right? If it's a 1 in 10 failure, then, oh, well, if they bump the README or they make a fix, but it's not actually a fix, but it green bars, and then it goes through to the next step, you've just selected for a bug that's inconsistent. So, if you decide, okay, well, I'm going to run the test suite twice in a row and it has to green bar both times, that 1 in 10 bug should be 1 in 100. So it's fewer, but you're just selecting down the number of chances that it's going to slip through. So I don't know. Hopefully that'll be an earworm and it'll chew on you a little bit.
Yeah. Very philosophical.
Quickly, two other things, because you talked about the debug logs, log levels. What's the right way of doing observability now in serverless from your experience? Is it still just logs? Do you already look into OpenTelemetry? Do you do other things? Because Brian and I, observability is a big topic for us day in and day out. So I'm just wondering.
Yeah, I mean, I think that I can't claim expertise on this in this area. OpenTelemetry as you say on the European pronunciation, is really intriguing to me. I've again just begun to get my feet wet in it, and looked at some of the different vendors in the space. It seemed that some of the early stuff that I was looking at seemed more well suited for running inside of containers, or running on, whether it's a kube platform or some flavor of EC2 or something like that. And so I don't know, I haven't found something perfect yet, or that I really have sunk my teeth into on the serverless side. I wish I knew more.
No, it's okay. Maybe listen to some of our other podcasts and then you learn more. That's one option of doing it. Yeah.
And Andy, before you go on, speaking of the open telemetry versus open whatever. Telemetry. Can you say metaphor for us?
Metaphor?
Isn't it metaphor?
Metaphor, yeah.
We had, that was way back. I remember way back we had our guest kept saying metaphor. And I'm like, guys, what's a metaphor?
Yeah.
And they were so I'm like, oh, metaphor. Okay. I was so confused. Sorry, I didn't mean to sidetrack, but it's just reminding. I had a flashback to that instance. You had a third thing you wanted to bring up, Andy, right?
Yeah, just one quick thing. You mentioned in the beginning the way you are kind of trying to find out the problem is you set the concurrency back to 1. Setting the concurrency back to 1 means you're forcing Lambda to really only stand up one container or whatever instance, one runtime instance at a time. Is this the way I understand it correctly?
Yes. How I understand how Lambda works internally, primarily based off of talk. I believe it was the 2018 reInvent, and I believe it was like the VP of engineering or the engineering lead on the Lambda team, and kind of walks through the core architecture. So people can sort of fact check me there. Is that setting that max concurrency to 1 is when a request comes in to Lambda, it'll take it on this kind of like receiver process, and then it'll look at its backend to see if there's any available Lambda instances to serve responses for that. And it has some amount of timeout that and I think it has some prediction about how long the average time to service a request is, so that it'll hold it a little bit and not spin up new instances, and it'll try to get ahead of if it's seeing a load spike. So there's all sorts of black magic that's happening inside of there. However, setting that max concurrency to 1 is saying no matter what happens, the backend should only spin up 1 instance of a Lambda. So essentially, you're only ever hitting the same memory space. If anything happens with that memory space and it decides that it needs to shut it down because there's an error in the runtime, or it needs to shut it down because of whatever AWS decides is the host that it's running on needs to get shut down. My understanding is it'll still recycle and get assigned somewhere else, but you won't have multiple copies.
Okay.
Otherwise, if you got 2 API requests that come in almost simultaneously, they could lead to 2 backend instances being spun up, even going from zero. So even from a cold start. So you get a cold start on both. Each one would serve. You'd essentially have 2 memory spaces sitting there, and then they'd both get torn down.
Yeah, and obviously the reason why you did it is because you wanted to, I guess, just focus on the one instance anyway. That means not getting flooded with too much information, too much logs from multiple instances. And I guess also for a cost reason, right? If you're executing a load test and then you really on it just focused on identifying the problem of a single instance, then just narrow it down to a single instance and that's it. Yeah, makes sense.
Yeah. And to be clear, like we didn't add that as part of our integration tests going forward, right? That was just a one-time, hey, we have this theory, can we prove it? So that we know the mechanism by which we're, that's sort of the scientific method of if you truly understand something, you can replicate it.
Yeah, cool.
So now you just designed your test so it doesn't account for that and it allows things that.
That's true, and we accepted that. That's the beauty of engineering. You say, and it's good enough.
Right. I had one question, if I can get in, about you mentioned that these were lessons learned on AWS Lambda. Andy, I can't remember who we had on a little while back. We were talking about our development of our, the Kubernetes version of Dynatrace and how it was different for AWS, different for Azure. There's different disks and all that. I assume, Kam, but I don't know if you've had experience that you can talk to, that what you find in AWS Lambda Serverless may or may not translate to any of the other serverless components either. So this complication you're dealing with of, we're going to use this supposedly easy thing where we can just write our code and push it out, but now we really have to understand what's going on in the hood. That seems like there's a pattern where when people are doing these things, they're going to have to repeat that step process over and over again for each cloud vendor they go to, because no two are completely alike in that sense. Is that, I don't know if, I know you said you didn't really have too much experience with those, but do you have any inkling if that might be the case?
Yeah, I mean, that's generally my understanding. Sort of the data point I base that off of is talking to sort of a CTO, short-term CTO for hire with, I think, a Fortune 1000 company in the US that did a big migration of a lot of their internal systems and was doing a bake-off between AWS and Azure. And he was telling me some stories about how the Azure serverless functions, again, and this might be 3 or 4 years old, and I haven't kept up to date, but the Azure serverless functions were having a much harder time handling any sort of bursts in load. It seemed that their load prediction algorithms were not as good at spinning up additional instances, and their cold start times were worse. I've noticed on Lambda, consistently cold start times are going down. So I don't know how much of that is the predictive spinning up instances ahead of time, which it seems to do a great job of, or they're just getting much better at spinning up runtimes, and that the efficiency of the startup is much faster. But yes, back to your point, is that my understanding is that these subtleties will be different across different cloud providers. And I've also noticed in other, I would consider code build a serverless service. I've noticed some significant differences in startup time on code build across AWS regions. So, for example, we run our main application in 3 different regions just to provide better service to our end users. And we noticed that Sao Paulo has a significantly slower cold build startup time than we'll see in either Mumbai or Ohio. So, I kind of extrapolate that across other services. And, the scuttlebutt I hear from AWS insiders is that their region parity, they're always, what's the polite way of putting it? They're looking to improve their region parity. And so even one service might not have the same level of, robustness or, capacity in some of their different regions. So,
and they may also have different hardware just running there, right?
Yeah.
And that's what it is. Yeah.
I think it throws a complication into the idea of evaluating different cloud platforms for what a company might want to choose as well, because this might not be the case in that AWS example. I mean, in the Azure example you mentioned, but it could be that whether or not it's serverless or anything else, it's optimized to run with a slightly different architecture. And if you're not aware of that optimization and you're trying to just port over your Lambda function and the way you have that to run to another platform without knowing what their optimal approach might be, you might be like, oh, well, their performance is terrible. But if you were to have that secret sauce of what they're designed to operate optimally on, you might be able to compare. So not only is it hard to, I guess, maybe compare different features and functions potentially on the different platforms, but even if you want to be multi-cloud, let's say you want to spread yourself amongst different vendors, you might have to have some architectural changes and differences based on what's going on under the hood and what's the best way to write for those processes, whether it's serverless or anything, right? But that's more and more complications as we make things simpler,
Yeah. So that I don't have experience in that. My career has primarily been at sort of the beginning end of the curve as far as time. So most of my software has been at the, from inception. So from day 0 through, maybe year 10 of the life of a system. So some of these much longer in the tooth, been running for 20, 30-year kind of systems. I don't have nearly as much experience on that. I think the oldest running system I've ever had is I ran some PBX software on when they were had it running on some desktop machines and stuff like that. So I don't really have experience with these longer, more enterprise where you're like, oh, we're going from on-prem and now we're migrating into, should we go to Azure or AWS and let's do a bake-off and stuff like that. So but that sounds right. Your theory sounds right to me.
Hey, Cam, considering the time, we have about 10-15 minutes left. I would like to give you a second shot at a second topic, whatever you choose. I know you have plenty in your presentation.
Yeah.
What else should we talk about?
I think S3. That's probably the most well-known, most used service. And again, sort of this subtlety, going back to your point, Brian, on that, is that with S3 in an application, early on you have to decide what's your pathing structure, right? That's something that has to happen before you can write your application. And so you can read best practices or whatnot. And so when the system that I had been working on, I came in and the pathing structure had already been decided, and there was we were using the global S3 domain name, and then we were using a path with a date in it. Our understanding at the time was that the date would provide some randomization and allow the S3 system to shard our files across however they did it, across clusters or individual computers. And so, things worked fine until we started storing more and more data in S3. And then we turned Athena on and pointed it at S3. And so Athena, my best way of describing it is it seems to use these 429s with S3, which I think is 429 is the too many requests, right? It seemed to be a network flow control discussion that Athena would use to size how much data it could pull from S3, which was fine for Athena, and it was fine for S3. S3 didn't really complain. We couldn't even tell it was having problems until we turned on extended metrics and looked at it. But our core application was trying to write to those same to that same bucket, and so we were getting write failures because S3 was getting saturated. Essentially, the I/O was getting saturated on each of these clusters or inside of each of these shards. And later, what we learned is that internal to S3 at the time, they used sort of a progressive path-based hashing. So they would just try to find a prefix that was consistent, and the first character that varied, they would try to shard based on that first character that varied. And so in our case, it was a date. And so that was the first character that had variability in it. So everything that was temporally the same or close to each other would also be on the same shard in the S3 backend. So then when Athena was trying to do a date report, it would just bombard this one shard and hotspot it. So I think Amazon has done some more hash-based sharding. I can't speak to whether they fixed that or not. In general, the way we kind of got around this was that we replicated the data from one bucket in East 1 to a bucket in East 2. And then we started running the reports off of that East 2 bucket. So S3 is fine, replicating the data for you. It's a nice little easy thing to turn on. And S3 was fine getting all those 429s, right? It's not a problem for it. So Athena was fine running off of that other bucket. Kind of the side effect, though, was another way to fail there, was that we never moved the Athena process from East 1 to East 2. So then we got to continuously pay AWS for their network egress from East 2 back to East 1 to do the analysis and put together those dashboards. So, again, one of those things where, it works fine, and you might not notice it until you start digging into the cost reporting and really dig through the tags. The other place, and I don't know if you noticed it in my description just now, but S3, there's a subtle, the experience of S3 is that it's this global service, but S3 is actually a regional service. And you notice this when you create a bucket, right? You have to create it in a region. And so, yes, there's naming problems that if you're not thinking about it at the time, like you might create, some bucket name in East 1, and then you go to create a second bucket in East 2, and now you can't create bucket name in East 2. So there's a little bit of a headache there, kind of the common practices to append the region name. But then you have this other issue of that, at least for us, we were using the global reference to that bucket, and so not the regional DNS name, host name. So that meant we had another level of indirection. So we were hitting a DNS server in East 1 to get the global name for that bucket. And then that was then giving us access to that S3 bucket. Now, I believe it was early 2019, AWS had a DDoS attack against those global S3 DNS servers, right? It's coming back to your previous podcast on it's always DNS under the hood, right? Like every failure is DNS. And then, so those servers went down or they got swamped. And even though S3 was still up and the service was still existing and the regional, so if we had referenced it by bucket name dot US East 2 or US East 1 dot, and then the S3 pathing, we could have gotten access to the data, and all of those servers were still connected and available. We were unable to access, and our core system went offline because we didn't have DNS, which got made more complicated because our whole build system also relied on those same S3 global paths. So you get into these interesting, kind of recursive dependency problems there. So. So that was a couple ones. I know you, Andres.
No, that's perfect. No, that's perfect. Yeah, I was actually. It's funny looking through the presentation that you did. It was actually the one that I picked. I would have picked myself. I would have hoped you picked with S3. So it's perfect.
Good.
Yeah. Kam, is there? I know we will link to the presentation. We will link to Cyclic, your website. Is there any other material that you've put out there, any other speaking slots, anything else where people can maybe, reach out to you or see you and meet you in person?
Oh, yeah. I don't think I have any speaking slots on the calendar going forward. I'm not on the conference circuit as much as you are. Maybe I should up my conference speaking game. But reach out to me on Twitter. I'm sure we can put that up. And definitely Kam.Lasater@cyclic.sh. Happy to respond to any emails that humans are willing to send me.
So this was a shout out also to all the bots out there that are sending fake emails. Feel free to use that as well.
Isaac Asimov is rolling in his grave.
Yeah.
But it was really great, and I think these are, as you said, it's great to talk about these stories where things didn't go as expected, or where you learn something new about the complexity of the technology we're really working with, even though the producers of the technology are making it sound like it's very easy anyway, because they hide the complexity. But it takes people like you to educate everybody out there, right, that wants to become successful with technologies like serverless. So thank you so much for that.
Yeah, absolutely. Yeah. If anybody has a story, I'd love to hear it. Record a little YouTube video or write up a blog post. I really want to trigger other people to kind of, come out and share with the world the ways they've hit the wall or caught something on fire accidentally. So we've all done it.
Yeah, it reminded me when you were talking about the idea of sharing the failures, it reminds me of the Titanic, right? It's like, well, we all pay attention to the fact that the Titanic hit an iceberg, right? And if that wasn't shared, there might be others. But when's the last time you heard about a cruise ship sinking on an iceberg? Not, right? Because they shared that. They thought they were indestructible, and now people don't crash in icebergs. It's like, avoid them. Hey, great lesson. But it's so important that you're sharing this stuff, and I think that's just fantastic. I was looking over the PowerPoint, yesterday as well, and these are the things that I love. I love hearing these stories of, I don't want to say I glory in them by calling them stories of failure, but I think those are the more interesting things to learn from, right? Because what works for people, it's not going to work in other situations, but what fails for people is something we can all take and make sure we don't do. So I really appreciate what you're doing, and thanks for being on today.
Is James still doing the News of the Damned?
I don't know. I haven't really been. I got myself, as part of my mental health, I got off of Twitter as well. Okay. So I'm not following if he's doing that. But that was always a fun show. If it's still out there, people go listen to it, and there are the great archives too. So Kam, our friend James Pulley, I think it was about a weekly podcast, would do News of the Dams, and he'd comb through all like Twitter and news things to find out the different crashes and downtimes different organizations would have. And sometimes he would try to get someone on, but he would also just, I think, try to surmise what may have happened but good stuff.
Yeah. Awesome.
All right, awesome. Everyone, thanks for listening. Kam, thanks for being on today. And if anybody has any questions or comments for Kam or whatever, we'll have his information posted in the show notes. If you have any questions or comments for us, you can reach us at pure_DT@dynatrace.com or tweet us at Pure Performance. I haven't been on that in a while. Pure Performance on Twitter as well, right? Is that the, I don't even remember what the handle is.
It is, yeah.
I haven't paid attention to that. Either way, just, send us a note with some money and we'll talk to you. And, thanks, everyone. Kam, thanks again for being on. Andy,
yeah, absolutely.
Go grab some candy.
Yeah, will do. Bye-bye.
All right, see you.